Hello, my name is Sara Concas, and in this video I will talk about the main results of my PhD research. But actually, this is not my face. This is a deepfake created using the face of my colleague. This is my real face. Here we have some information about me. I obtained my bachelor and master degrees here in Cagliari, and I have been a member of the biometric unit since 2020, when I started my research on deepfake detection. These are my colleagues from the biometric unit of the Department of Electrical and Electronic Engineering, my co-supervisor Giulio Ru, and our leader and my supervisor, Professor Gianluca Marcialis. My main research topic, as you might have already guessed, is deepfake detection. Starting from an image or video, the goal is to discover whether the identity or behavior of the people involved has been manipulated in any way. I have also worked on the problem of 3D face reconstruction from a 2D image, specifically aiming to leverage the complementarity of state-of-the-art systems to create a more reliable and robust solution for face recognition. Another topic I have addressed is iris recognition, particularly under varying and challenging environmental conditions. Now let's talk about the main topic of my research, the problem of deepfake detection. With the term deepfake, we identify all the techniques used to create fake content representing humans, mostly using deep learning. We can have different types of deepfakes. Some are created by replacing the face of a person with the face of another person. Some other are created just modifying the expressions and movements of the mouth. Some others modify an attribute of the face, such as gender or age, and some others are totally artificially generated, creating faces that don't actually exist. Here is the main contribution of my research. Starting from a video, we extract the frames, and then from each frame, we extract some specific patches, like the face, the eyes, and the mouth. Then we compute some quality scores from these patches and use these scores to classify the entire video as real or fake. The hypothesis is that a manipulated sample contains artifacts even when they are not visible to the human eye. In this other work, we attempted to exploit the complementarity provided by different versions of the same image, resized and compressed in various ways. For each of these images, we computed the discrete Gaussian transform and used all this information for classification. A system of this type allows the correct classification of samples as fake, even they have been shared via social media and therefore resized and compressed. Complementarity was also exploited in this other project, where various well-known state-of-the-art algorithms were used to calculate the probability of a given sample being fake. These probabilities were then combined in different ways to achieve the final result. Thanks to this method, it is possible to leverage the capabilities of the different detectors for greater robustness. Once again, complementarity was utilized in this work, where the image under examination is decomposed to separately evaluate texture and artifacts, two aspects often used independently for deepfake detection. In this case, we leveraged both pieces of information to maximize the complementarity of the two approaches. Complementarity was also exploited outside the scope of deepfake detection. In this case, starting from a 2D image, we applied various state-of-the-art algorithms for 3D face reconstruction. The complementarity between these algorithms was leveraged to improve the performance of a facial recognition system based on 3D face reconstruction. Regarding iris recognition, our main contribution is a dataset that includes 27 different subjects. In addition to acquisition under normal environmental conditions, each subject was also captured while wearing glasses and under red and blue colored lights. This was done to test the performance of state-of-the-art systems under challenging conditions. During my PhD, I also had the opportunity to spend a research period abroad at the Autonomous University of Madrid. I had the chance to work with a renewed international group led by Professor Julian Fierretz, while simultaneously experiencing a different culture. Of course, I didn't spend all my time drinking sangria. In addition to leveraging the extensive knowledge of Professor Ferret's group to continue developing my main research topics, I was also able to participate in the synthetic data for face recognition competition organized by the IDIAP Institute. The challenge consisted of training facial recognition system using only synthetic data to overcome the limitation of these systems related to privacy concerns. The training system was then evaluated on real faces to compete with traditional systems. Thank you very much for your attention.